Next we have methods of preparation of alkyl halide from alcohols. Alkyl halides can be prepared from alcohols. The statement says alkyl halides are best prepared from alcohols. We have alcohol, ROH. It can be primary alcohol, secondary alcohol, or tertiary alcohol. Okay, which are easily accessible, means which are easily available. From the easily available alcohols, alkyl halide can be prepared. The next statement is hydroxyl group of alcohol. We have alcohol and this is the hydroxyl group of alcohol. Okay, is replaced by halogen. Halogens are represented by X. We can say Cl, it is Br, or it is I is there. Okay. On reaction with concentrated halogen acids are nothing but hydrogen halide. We can represent as HX. We can write HCl, yeah, HBr, or we can mention HI is there. So in this case, we can make it react with HX, hydrogen halide. Hydrogen halide in the sense it can be HCl, it can be HBr, yeah, it can be HI. So we have to take concentrate. So in this case, what will happen? If I take HCl, so what will happen? H and OH will eliminate from here, and Cl will attach to alkyl group, and we get alkyl halide. Okay, we have alkyl chloride is there. If I take HBr, alkyl bromide. If I take HI, alkyl iodide. Okay. Next we have phosphorus halides. Phosphorus halides in nitrogen family you might have learned about PCl3 and we have PCl5 in organic chemistry. Sorry. PCl3 or PCl5. You can see any of these halogenating agents. What is the property of halogenating agents? They replace OH by the halogen. Okay. They introduced Cl in place of OH. These are the chlorinating agent, we can say. Chlorinating agent. This is also chlorinating agent. Okay. Next we have thionyl chloride. The chemical formula of thionyl chloride is what? SOCl2 is also there. So you can see good number of halogenating agents we have. HCl, PCl3, PCl5, SOCl2 is also there. Okay. But it says thionyl chloride is preferred because the other two products are escapable gases. Out of these halogenating agents, thionyl chloride is preferred one. Why it is so? Because we can understand. Let me remove this portion. What happens when alcohol reacts with thionyl chloride? This is what we have. OH is there, and we have thionyl chloride. In this case, the structure of thionyl chloride is something like this. Okay, these two Cl are separated from here. So in this case, we get a 2Cl, and this is what SO is there. I'm just talking about what is the portion, how it is breaking. Okay, OH will be removed, and one Cl will come here. This is what RCl is there. Okay, so one Cl is removed. Here we have OH. This portion is left. Okay, so what happens exactly? This hydrogen and this Cl will combine forming HCl. It is a gas, and then SO and oxygen combining forming SO2. This is also a gas. So these two are the escapable gases. We have escapable gases. So automatically these two gases will escape from the reaction and we get only pure product, alkyl halide. So this is the reason out of HCl, PCl3, PCl5, thionyl chloride is preferred, because in this case it says hence the reaction gives pure alkyl halide. We get the pure alkyl halide, we do not get any bioproduct. Automatically these two gases will escape. Okay. Next we have phosphorus tribromide and triiodide are usually generated in situ. Situ in the sense produced in the reaction mixture. Okay, they are produced in the reaction mixture. How they are produced? By the reaction of red phosphorus with bromine and iodine respectively. Okay, if we take red phosphorus and reacting with Br2, bromine is there, so we get phosphorus tribromide is there. If you want to balance this equation, multiplied by 2, multiplied by 2 and multiplied by 3. Okay, so by the reaction of red phosphorus with bromine, we get phosphorus tribromide. Similarly, we can get red phosphorus reacting with I2. So in this case, we get Pi3 is there, multiplied by 2, multiplied by 2, multiplied by 3. Okay. These are the halogenating reagents. Next it says the preparation of alkyl chloride is carried out either by passing dry hydrogen halide gas. Dry hydrogen halide gas is nothing but a halogen acid. Okay, hydrogen halide is nothing but halogen acids. It says hydrogen chloride gas through a solution of alcohol. If the dry hydrogen chloride gas is passed through the solution of alcohol, we can prepare alkyl halide. Preparation of alkyl halide can be carried out by passing the dry hydrogen chloride gas through a solution of alcohol. Okay, so let me write this reaction. We have alcohol is there, and if we take dry HCl, so in this case we can produce alkyl halide. Okay, this H2 will be eliminated from here. Okay, further it says by heating, alkyl halide can also be prepared by heating a solution of alcohol in concentrated aqueous solution. Then in place of dry HCl, we can use concentrated aqueous solution of HCl. This is concentrated and this is your aqueous. It is not dilute. Okay, concentrated HCl is there, but some quantity, but less quantity of water is there. So in this case also you can see OH and H will be eliminated and we get alkyl halide is there. In general, concentrate acid is used. General, keep in mind concentrate acid, conc acids act as a dehydrating agent. Okay, in this case H and OH will combine forming water molecule, and this water molecule will be eliminated by dehydrating agent. It will burn. So that's why we are using concentrate HCl. And if we do not use concentrate HCl, whatever the water molecule is formed here, this water molecule will react with alkyl halide, and again the reaction will go backward direction. So this is the reason we use dehydrating agent. We maintain concentrate solution. Okay, this part is very clear. Okay, next we have the chemical reactions. Pay attention carefully. Following chemical reactions are there. You can see the first chemical reaction we have alcohol is reacting with hydrogen halide, but question is why we are using ZnCl2. Okay, in this case you can see OH and H can combine and alkyl halide is formed, water molecule is liberated. So let's say if I talk about alcohol, ROH is there and it is reacting with hydrogen halide, remove water molecule. Okay, we get remove water molecule and we have alkyl halide is there. X can be chlorine, bromine, or it can be iodine is there. Okay, but why we are using ZnCl2? Keep in mind ZnCl2 is acting as a dehydrating agent. And dehydrating agent job is to remove water molecule. You can see whatever the water molecule is formed in this reaction, so this dehydrating agent will absorb this water molecule, so that this water molecule should not react with this alkyl halide and convert back into alcohol. Reaction should not go backward direction. This is the reason we use dehydrating agent. Either we use concentrate acid. So concentrated acid also acts as a dehydrating agent. It can burn water. Whatever the water quantity is there, whether it burns, it absorbs, it removes the water quantity in the reaction, so that the reaction should not go backward direction. Okay, very interesting part. Next reaction we have ROH. Keep in mind this is a salt and this is what H2SO4, strong acid is there. How does this reaction takes place? We have ROH is there reacting with NaBr and we have H2SO4. We can say we have H2SO4. In this case, keep in mind H2SO4 is a strong acid. Okay, it can dissociate into H plus and HSO4 minus. Okay, we have NaBr. This is salt. It can also dissociate into Na plus and minus is there. Okay, what happens? This H plus ion will combine with Br minus. So we get HBr and we get NaHSO4 plus minus attraction will be there. This portion will combine. Okay, from here we are getting a strong acid. So you can see this mixture exactly giving us we have HBr and we have NaHSO4. Okay, so in general this alcohol is reacting with HBr and SO4. So we have ROH reacting with HBr, and we have NaHSO4 is there. So what happens? Will be removed and Br will attach. We get RBr is there. RBr. From here, water molecule is liberated. We are having dehydrating agent. Strong acid is there. Strong acid. So it can burn water molecule, so that reaction should not go backward direction. Okay, it should not go backward direction. Anyway, if we get water molecule, this water molecule will be absorbed by this NaHSO4. What will happen? We have NaHSO4. If you dissociate from here, this is Na plus. This is what? We have a minus is there. It will have minus sign. Reacting with what? H plus, and this is OH minus sign is there. So we will convert into what? NaOH and H2SO4. Okay, neutralization reaction will be taking place. Strong acid, strong base. So this water molecule which is liberated from here will participate in the neutralization reaction and इसका काम खत्म हो जाएगा. ठीक है? So it will not have any impact on the final product. Next reaction we have alcohol reacting with phosphorus halides. Okay, we have alcohol ROH is there, and in this case PCl5 we can take. No, sorry, PCl3. First we have PCl3 is there. Okay, where it is talking about X, it is talking about where X, chlorine, bromine, iodine is there. Okay, so how does this reaction takes place? You can see there are 3 Cl are there, 3 Cl. Okay, and in this case each Cl can substitute OH, each Cl, and there are 3 Cl, so I need 3 OH, so multiplied by 3. Okay, so from here we get R, and it is Cl is there, 3 Cl. So you can see all the 3 Cl replaced all the 3 OH. Okay, from here we got 3 OH minus one is there, and phosphorus is also left. So this phosphorus and 3 OH will combine together forming H3, and it is what? PO3 is there. This is how the reaction taking place. Okay, H3PO3. In this reaction, all the halogens are, you can see 3 molecules of OH are replaced by all the halogens. But it is not so in case of PCl5. Why it is so? We understand. If we talk about ROH and it is reacting with PCl5 is there. So in chemical bonding, you might have learned, if we talk about the geometry of PCl5, so it is having how many bonds? 5 sigma bond. And in this case, hybridization will be sp3d, and means it is having trigonal bipyramidal structure. So phosphorus is present here. Let's say it is phosphorus, it is Cl, and it is Cl, it is Cl, and here we have Cl. Okay, so you can see this is equatorial position, stable state is there, but this is axial because repulsion will be there. Lone pair repulsion is there. So the bond length of these 2 Cl is quite high, so these 2 Cl are removed. So in general, this PCl5 can remove the 2 Cl and converts into PCl3. Okay, these 2 Cl will be participating in the reaction. 1 Cl will substitute, replace OH. So what will happen? 1 Cl, so we got RCl is there, plus from here we got OH. Okay, 1 Cl will replace OH. Okay, so 1 Cl attached. So 1 Cl is left here. From here we got only 1 Cl. We have OH. From this hydrogen and Cl will combine forming HCl. Okay, next we have oxygen is there. This oxygen, what is left? PCl3 is left. So we have POCl3 is there. Okay, so these are the final products we have. So in case of PCl5, you should be careful. All the halogens do not participate in the reaction, only 2, because 2 Cl in trigonal bipyramidal are present in the axial position. In that case, bond length is quite high. So that's why only those 2 Cl are removed. Okay, it is given in chemical bonding. Next, we have alcohol reacting with red phosphorus and halogen is there. So in this case we have learned, if I take halogen, it is Cl2, yeah, Br2, and it is I2 is there. So we can mention red phosphorus, or in this case directly we can also mention, let's say it is giving this mixture, PCl3, PBr3, Yeah, Pi3 is there. I will talk about PCl3. So similarly, we get a RCl is there, and in this case we get H3 and PO3 is there. This reaction is quite similar. This reaction is quite similar to this reaction. Same reaction only, because this mixture will give phosphorus trihalide. Same reaction. And this reaction is the preferred reaction. You can see out of all these reactions, this reaction is preferred reaction, because in this case we get the gases. This is what sulfur dioxide gas, this is also a gas. So these two gases are escapable gases, will automatically escape from the mixture, and we get the pure alkyl halide at the end of the reaction. That's why this is the preferred reaction. The next statement says the reactions of primary and secondary alcohols with hydrogen halide. We have primary alcohol, let's say we have CH3, it is CH2, it is OH is there. And we have secondary alcohol CH3C, and it is S, we have CH3 and it is OH is there. This is primary alcohol and this is secondary alcohol. Okay, carbon attached to single carbon primary alcohol, this carbon attached to two other carbon secondary alcohol. Okay, with hydrogen halide, when these primary and secondary alcohols are reacting with hydrogen halide, they require catalyst ZnCl2. Okay, so that rate of reaction could be faster. But interesting part is that it says that tertiary alcohol, the reaction is conducted by simply shaking with concentrate HCl at the room temperature. Remember, tertiary alcohol, in case of tertiary alcohol, when we convert a tertiary alcohol into alkyl halide, we don't need catalyst ZnCl2. Only in primary and secondary alcohol we require catalyst, so that rate of reaction can be increased. But in case of tertiary alcohol, we do not need any catalyst. Let's say we have tertiary alcohol CH3 and we have CH3, it is what CH3 is there, this is what OH is there. In this case only conc HCl is taken, and easily we can produce CH3C, CH3 there, this is what Cl is there. This is tertiary alkyl halide, this is tertiary alcohol is there. Okay, we don't use catalyst in this case, and in this case we use catalyst. In the presence of catalyst will be taking place, reaction will be taking place. Okay, so we can say reaction of tertiary alcohol is much more faster in second of in the comparison to primary and secondary. Why it is so? But the conclusion which we have found here from this statement, if we have primary and secondary alcohol, so in this case we can take conc hydrogen halide, but catalyst ZnCl2 is used. Okay, then we get primary or secondary halide. Okay, conclusion up to this statement from here. But if I take tertiary alcohol, in this case we use only conc HCl, we don't use catalyst. Catalyst is not required, and tertiary halide is produced. Okay, we understand why it is so. If we talk about the reactivity of alcohols, we have primary, secondary and tertiary alcohol. So keep in mind, this is what we have. Let me write this is primary CH3 CH2, it is OH is there. Secondary CH3 CH, it is OH, and this is CH3 is there, and we have CH3, it is C, it is OH, and it is CH3 and it is CH3 there. This is primary and this is secondary, and this is tertiary alcohol is there, tertiary alcohol. Okay, in this case we understand in which case OH group can be removed very easily. In this case if I remove, so we get a tertiary carbocation. If this remove, we get secondary carbocation. If I remove this OH, we get primary carbocation. In general organic chemistry we have learned tertiary carbocation is much more stable than secondary. Secondary carbocation is much more stable than primary, the stability order of carbocation. So you can see in tertiary alcohol we are getting stable carbocation, tertiary carbocation we are getting. So you can see tertiary alcohol is having a greater tendency to remove OH so that it can get the stable carbocation. By removal of OH, it is getting instability. So it has greater tendency to attain the stability. It does automatically removal of OH. Very easy, OH group can be removed. In this case, stability is there, but stability is lower in comparison to tertiary. We are getting secondary, and this is what primary carbocation. So removal of OH in case of tertiary alcohol. Keep in mind the alcohol which removes OH group at the faster rate, its participate in the reaction will also be faster, and it will be producing the product at the faster rate. So that's why you can see tertiary alcohol can participate in the reaction even at the room temperature and it does not require any catalyst. Only primary and secondary alcohols are requiring catalyst. In case of tertiary alcohol to convert into alkyl halide, there is no catalyst required. Very interesting part. Okay. Next we have constant boiling of HBr 48%. It says HBr should be 48% is used for preparing of alkyl bromide. If we have alkyl alcohol, in this case if we have HBr and 48% HBr is taken and constant boiling is maintained, so we can produce RBr, alkyl bromide is there. In this case water is also produced because we have OH and H will be removed. But since boiling is continued, so it will evaporate, it will burn, so we get the final product. Okay. Next we have good yields of alkyl iodide may be obtained by heating alcohol with sodium or potassium iodide in 95% phosphoric acid. Okay. Now it is talking about the production of alkyl iodide. So we can have alcohol. What does it mean by alcohol? And it can be converted into alkyl iodide. And reaction is what? Good yield of alkyl iodide can be obtained by heating alcohol. By heating alcohol, heating is done. With the sodium or potassium iodide, either you can take sodium iodide or potassium iodide is there. And in this case, presence of 95% phosphoric acid H3PO4 is there. Okay. So you can see we get H2 in this reaction. This OH will be replaced by I will come here. In case if you are getting water molecule will be burned by strong acid. Okay, 95% concentrated H3PO4 is there. So in this case we get better production, better quantity of the product. Okay. This is the method for the alkyl bromide. This is the method for alkyl iodide. Earlier methods we learned about alkyl chloride. Okay. Next important part we have, it says that the order of reactivity of alcohol with given halo acids. Halo acids are nothing but hydrogen halide. Let's say we have hydrogen halides. These are the halo acids HCl, HBr, HI. These are the halo acids, halogen halides we can say. With given halo acids is tertiary, secondary and primary. Tertiary alcohol is much more reactive than secondary. Secondary alcohol is much more reactive than primary. Why? Because tertiary alcohol after removing OH get stabilized. We get a tertiary carbocation. Tertiary carbocation is more stable than secondary. Secondary carbocation is more stable than primary. Okay. So this is why tertiary alcohol is much more reactive. This is the important part. The above method is not used to applicable for the preparation of aryl halides, aromatic halides, because carbon oxygen bond in phenols has a partial double bond. It says that if we take phenol, yeah, it's one way we can say we have a aromatic alcohol. And if you talk about conc HCl if you are taking, and if you think in a similar manner if you can produce into aryl chloride, this reaction is not possible. You cannot apply the logic H2O will be removed from here and Cl will attach here. It is not possible. Why it is so? It says because carbon oxygen bond in phenol has partial double bond. This is carbon, this is phenol, we can say phenol. Okay. Phenol structure, this is what we have. This is phenol is there. Phenol. Carbon oxygen is having partial double bond. We have only single bond. How we are getting partial double bond? We understand. Okay. You can see we learn about resonance. Okay. Resonance is possible when the conjugated system is there. And keep in mind the system which has resonance, its stability will be higher. Yeah, we can say bond order. Your bond strength will be increasing. Okay. Because pi electron density will be making a movement from one atom to another atom. And where the resonance is possible, where the conjugated system is there. Keep in mind if you are double bond, single bond and double bond, resonance will be there because it is considered as a conjugated system. Double bond, single bond, positive charge, conjugated system, double bond, single bond, negative charge, conjugated system, double bond, single bond and lone pair. Keep in mind any of these system are given there, they are considered as a conjugated system and resonance will be there. Any of these, double, single, double single, positive, double single, negative, double single, lone pair. Okay. So if we talk about phenol, you know, we have phenol. Okay, we have phenol is there. We have phenol. This is phenol is there. Okay. If you look here, you can see double bond, single bond, lone pair. So double single positive charge, double single negative charge, double single lone pair. Lone pair is there, means this is part of conjugated system, means resonance will be there. When this electron density as a part of resonance moves, so due to the repulsion, this electron density will move in opposite direction. Okay, this electron density coming this side as a part of resonance, moving this side. So you can see one lone pair is capable enough to form one single bond, because one single bond carries how many electron? 2 electron. One lone pair has 2 electron already. Okay, so when it is moving this side, it will be creating one more bond. Okay, so something it will be there. We have double bond, oxygen, one lone pair, it lost one lone pair, partial double bond. Now it will be carrying negative charge. So you can see partial double bond due to the resonance is generated. And when double bond is generated, so as the bond order increases, bond stability increases, stability of the system also increases, bond dissociation enthalpy also increases. So you can see between this carbon and oxygen, due to the resonance, bond strength increases. So breaking of this bond is not that much easy in comparison to aliphatic alcohol. In this case, there is no resonance. Okay, there is no resonance because it does not have any conjugated system. Keep in mind, breaking of carbon oxygen bond in tertiary alcohol is much more easier, because if we break it, we get a stable carbocation. In this case, we cannot break because partial double bond is generated because of the resonance, because it has conjugated system. Double single lone pair, we can say a double single lone pair. So this is what it says, that phenol has a partial double bond character. Phenol, this is phenol, and it has partial double bond character. Partial double bond character is there, which is difficult to break, being stronger than a single bond. It has double bond and it has single bond. So double bond strength much more than secondary as double bond, and then much more stronger than a single bond. If you like this video, please share and subscribe to the channel.